Okay, so for this question, we want to look at finding the equation of the normal at P, where theta equals pi over 6, and the curve is given by the parametric equations x is equal to 3 sine theta and y is equal to 5 cos theta. So if we're looking at equations of normals, we should be thinking, right, well, we need to step that back. If we're looking at normals, we need to think about a tangent. So if we're thinking about tangents, we need to step it back to gradients. And if we're stepping it back to gradients, then we should be thinking our differentiation. We've got our curves there, so we need to find an expression for, or a value for dy by dx, which indeed we do. So to find dy by dx, these are both in terms of theta, they're given parametrically, so we're going to need to differentiate our two expressions here, such that dx by d theta is equal to 3, the differential of sine theta with respect to theta is cos theta, and dy by d theta, differential of cos is minus sine, so minus 5 sine theta. So from that then, dy by dx, if we multiply this through, dy by d theta in our numerator is minus 5 sine theta divided by multiplying 1 over 3 cos theta, or in the denominator 3 cos theta, which is the same as minus 5 over 3 tan theta. So that's our expression for dy by dx for our gradient. So we can now get a value for this because we are given that as theta is equal to pi over 6, that implies that dy by dx is equal to minus 5 over 3 tan of pi over 6, which is minus 5 over 3, as you should know, or your calculator tells you, that tan of pi over 6 is root 3 over 3. So tying that up a little bit, you've got minus 5 root 3 over 9. So then we need to go back to our question, and it says, well, we want the equation of the normal. Well, we've just found the gradient, and specifically dy by dx is the gradient of the tangent. So we need to remember a connection here, that our gradient of our normal is minus 1 over the gradient of the tangent. It's the negative reciprocal. So you've got minus 1 over minus 5 root 3 over 9, which becomes 9 over 5 root 3, or when we rationalise that, you end up with 3 root 3 over 5. Okay, so this is now our gradient of the normal. But we don't want the gradient, we want the equation. So at this point we need to remember, if it's a normal, or indeed if it's a tangent, what is that? Well, it's a general function, it's the general function of a straight line. Okay, so there's two main methods for this. You've got y equals mx plus c, or y minus y1 equals mx minus x1. Personally, I prefer y equals mx plus c, but you're fine to use either method. Okay, so if we're going to look at y equals mx plus c though, we need to think, well, I've got a value for my gradient. Ultimately, I'm going to want to get a value for c, but actually we need to know two key other values first, which is for x and for y. And the same if we use y minus y1 equals mx minus x1, you still need to find the equation, the coordinates of a point on our curve. Well, fortunately, we're given a value for theta, and we're given two expressions for x and for y, so we can just substitute those in and get ourselves values for x and y for a specific point. So, when x is equal to 3 sine pi over 6. Sine pi over 6, or if it was in degrees, sine 30, you should know is a half. So x is equal to 3 over 2. And y, 5 cos pi over 6. Now cos pi over 6, or cos 30 in degrees, is root 3 over 2. So 5 root 3 over 2. So we've got our coordinates 3 over 2 and 5 root 3 over 2. We've got our general form of a straight line. We have our gradient. So all we need to do now is substitute in. So we've got our y value, which is 5 root 3 over 2, is equal to our m, which is 3 root 3 over 5, times our x value, which is 3 over 2, plus c. So a little bit of rearrangement then. C is equal to 5 root 3 over 2 minus 3 times 3, 9 root 3 over 10. And if we simplify that, then we end up with 8 root 3 over 5. So therefore, our equation of the normal at P is y is equal to our m, which is 3 root 3 over 5 x, plus our c value, 8 root 3 over 5. And that is our final answer for our equation of our normal at P, where theta equals pi over 6, and the curve was given parametrically by the equations x equals 3 sine theta and y equals 5 cos theta.